but let's take a look at section D, which is called compound events. And in particular, we're going to be looking at independent and dependent events. Now let's take a look at a situation here. Let's say, for example, that we have 3 blue marbles and 7 red marbles. These marbles are exactly the same except for color. And let's go ahead and just make sure that we understand the difference between what is called a simple event and a compound event. Okay. If we were to go ahead and just choose a marble, we would consider that to be a simple event. Okay. Now, if we were to go ahead and take a look at a compound event for the same situation, one thing that we could do is we could choose 2 marbles. So you choose 2 marbles. Or you could choose 3 marbles. So notice that the compound event is really something involving one or more simple events, okay, in sequence or simultaneous. Now, of course, what we want to do is we really want to be able to calculate probabilities of simple events. So, say for example, if we go ahead and choose a marble, the 2 outcomes that are possible, of course, is a red or a blue. So what I could then go ahead and say then is that if I go ahead and talk about the probability of simple events, let's put the S there, then what we could do is we could say what is the probability of a red, or in this case what is the probability of a blue. So if we go ahead and take a look at the simple event, here's the simple event of choosing 1 marble. Given that we have 10 marbles altogether, 3 of them blue, 7 of them red. And we know for a fact that with our ideas from theoretical probability, that the probability of red, in this case, would be 7 over 10. And the probability of blue would be 3 over 10. And you would be done. Very simple to calculate probability of simple events. Now, when we come to the compound events and calculating the probabilities of compound events, things get a little bit more tricky because we can always go ahead and choose 2 marbles in a variety of ways. Now, let's go ahead and think about what some of those ways are. Now, imagine that you have a bag and you have all 10 of these marbles in the bag. How many different ways can you choose 2 marbles? Well, I could actually take 2 marbles out at a time, or I could take one out, take a look at what its color is, put it back in, take another marble out, and do it that way. Or I could take 1 marble out, put it down here, take another marble out, put it out there. So there's different ways that you can actually choose 2 marbles. So, characteristics of compound events. This is going to be very important for us as there are different ways of actually choosing 2 marbles. We can either think about a situation where we do not replace. We do not replace after one event to actually calculate then the probabilities of the second event. So for example, we would call those dependent compound events. So if we had the bag, I would take it out, I would look at the color, I would not put it back into the bag, in other words, no replacement. I'd take out the next marble, and I would then go ahead and consider that to be a single type of compound event, in particular a dependent compound event, where of course the outcomes affect each other. Okay, let's go ahead and think about how we would actually calculate that. Now, if we go ahead and take a look at our tree again, here is the simple probability. Let's go ahead and take a look at the compound event where we actually take 2 marbles. So here's choosing the first marble, here's choosing the second marble. And notice that again we have red, and blue. But notice that being that this is going to be a dependent event where we do not have any replacement, what I'm going to do then is I'm going to say that, well, if I go ahead and choose a red marble, then there is really only going to be 9 marbles left. So there's only going to be 9 marbles left. Now, if I go ahead and choose, say for example, that I actually chose a red marble first, and I kept that marble out, and then I chose another one, there are now only 6 red marbles out of the 9. Of course, that means there are 3 blue marbles out of the 9. And if I was to go ahead and take a look at the 3 if I chose a blue marble for the first time around, for the first event. Then that means that I will only have 2 blue marbles to choose from out of the 9. Okay, and red would have 7. So if I wanted to go ahead and determine, say for example, the probability of choosing a red, then a blue, where I'm assuming that there is no replacement, then I would have to say then that the probability of choosing a blue, then a red, would actually be equal to the probability of choosing the blue, and then times that by the probability of choosing a red. Okay? Choosing a red, given that a blue was chosen first. Okay? So if I was to go about doing this here, using my tree diagram, the probability of B, which of course would be here, would be 3/10. And then the probability of choosing a red, assuming that I chose a blue before it, would be 7/9. And then I could just go ahead and say, this is 1, that's 3, that's going to be 7/30. Okay, so if we were to go ahead and talk about dependent events in general, I could then go ahead and say that the probability of A, then B, is the same thing as the probability of A times it by the probability of B, given that A occurred. Okay, and we know then that we can always use this particular formula to go ahead and determine the probability of a dependent compound event that doesn't include replacement. Now, another thing that we could always go ahead and do as well is say, what if we actually included replacement, or in other words, included replacement here. Now, let's say, for example, if I included replacement, I had a bag, I pulled up a marble, I looked at its color, and then what that means then is with replacement, I would actually put it back, shake it up again, and pull out another marble. So what that means then is that this here is going to be affected because I'm putting the marble back. So then that means then that the original conditions that we had for the first event, for the first trial, is actually going to be repeated for all the other trials as well. So we have 7 and 3 and 7 and 3. Okay, so let's go ahead and think about what we want to do then if we talk about independent. Now, if I wanted to go ahead and talk about what is the probability of A and B, so say for example I choose an A marble, put it back, then I choose a B, then what this means then is that I just follow my tree and say that, well, this is the probability of, A and B, let's say R and B, that I would actually choose a red marble and then I would actually choose a blue marble. Well, the probability of choosing a red marble is 7/10. The probability of choosing a blue marble in the second event or the second trial is actually 3/10. So this should mean that this is going to be equal to the probability of R times by the probability of B. So that would then be 7/10, 3/10. So that would actually give us a value of 21/100. So notice what happens then is that if I include replacement, these events are independent because of the fact that the probabilities of each one of these simple events are the same for each subsequent trial. So what I can do then is I can generalize and say then that the probability of A and B is the same thing as the probability of A times by the probability of B. Okay, and there you go. That's how we go ahead and calculate the probabilities for independent compound events and dependent compound events. Okay, so let's go ahead and see if you can work that out for these next 2 sections. And if there's any questions, let's take care of them tomorrow. Okay, thank you very much. See you next time.